Physical quantities and measurements. Measurement of density of irregular solids using Eureka can. A Eureka can or an overflow jar helps to find the volume of an irregularly shaped solid. Thus, by measuring mass of the solid using spring balance or beam balance, we can measure density of irregular solid using the formula density is equal to mass divided by volume. Activity. To measure the volume of an irregular solid using an overflow jar or Eureka can. Take an overflow jar made of metal or glass with an overflow outlet as shown in figure. Pour water into the jar till it just overflows. Place a measuring cylinder just under the spout of the overflow jar. Now, tie the solid to a thread and immerse it completely into the water of the overflow jar. If the solid is soluble in water, replace water with a liquid in which it is insoluble. The solid displaces water which overflows through the outlet pipe and collects in the measuring cylinder. The volume of the overflow water collected in the cylinder is equal to the volume of the irregular shaped solid. Let it be V. Let M be the mass of irregular solid. Then, the density of irregular solid is given by M divided by V. Using measuring cylinder. Again, by measuring mass using beam balance and volume using measuring cylinder, we can measure the density of irregular solid by the formula density is equal to mass divided by volume. Activity. To measure the volume of an irregular solid using a measuring cylinder. Take an irregular solid that does not dissolve in water but sink in it. Clean a measuring cylinder and pour some water into it so that liquid can completely immerse into it. Note the reading of the level of water in the measuring cylinder. Let it be V1. Now, tie a thread around the irregular shaped solid and immerse it completely in the cylinder. The level of water in the measuring cylinder rises up. Note the new level of water in the cylinder again. Let it be V2. The difference between the two readings in the cylinder will give the volume of the irregular shaped solid. That is, volume of irregular solid V is equal to V2 minus V1. Density of irregular solid is equal to M divided by V2 minus V1. Density. Density of a substance is defined as the mass per unit volume of that substance. Density is equal to mass divided by volume is equal to M divided by V. Unit of density. The formula of density is given as density is equal to mass divided by volume is equal to M divided by V. The SI unit of mass is kilogram and volume in meter cube. Hence, in SI system, the unit of density is kilogram per meter cube. It can be read as kilogram per meter cube. In small units, if mass M is in grams G and volume V is in cubic centimeter cube, then the unit of density is gram per centimeter cube or gram per cubic centimeter. The density of iron is 7.8 gram per cubic centimeter. It means that 1 centimeter cube volume of iron has mass 7.8 grams. Relation between kilogram per meter cube and gram per centimeter cube. In CGS system, the density of water is 1 gram per centimeter cube. Here, M is equal to 1 gram is equal to 1 upon 1000 kilogram. V is equal to 1 centimeter cube is equal to 1 centimeter into 1 centimeter into 1 centimeter is equal to 1 upon 100 meter into 1 upon 100 meter into 1 upon 100 meter. In SI unit, density is equal to mass upon volume is equal to 1 upon 1000 kilogram whole upon 1 upon 100 meter into 1 upon 100 meter into 1 upon 100 meter is equal to 1 upon 1000 into 100 into 100 into 100 kilogram per meter cube. In SI unit, water has density is equal to 1000 kilogram per meter cube. Therefore, 1 gram per centimeter cube is equal to 1000 kilogram per meter cube. The density of mercury in CGS system is equal to 13.6 gram per centimeter cube. So, in SI system, its density will be 13.6 into 1000 or 13,600 kilogram per meter cube. Relative density. A small piece of iron nail is lighter than a large piece of wood, but the density of iron is more than that of wood. In fact, when we compare the densities of two substances, we compare the masses of two bodies of same volume. Thus, the idea of relative density comes to our mind. Relative density of a substance is defined as the ratio of density of the substance and density of water at 4 degrees Celsius. It is denoted by RD. Relative density is equal to density of substance divided by density of water at 4 degrees Celsius is equal to mass of unit volume of a substance divided by mass of same volume of water at 4 degrees Celsius is equal to mass of any volume of a substance divided by mass of same volume of water at 4 degrees Celsius. As water is the most commonly used substance, so it is convenient to take the density of water as the standard value. The standard value of density of water at 4 degrees Celsius is 1 gram per centimeter cube. The densities of other substances are compared with the density of water. The relative density has no unit because it is in the ratio of two physical quantities. It is a scalar quantity. The instrument used to find the relative density of a liquid is called relative density bottle, shown in the figure. It is a small glass bottle which has a stopper with a fine hole. This bottle is used to find the mass of equal volumes of liquids. Measurement of density of fluids. The method by which the density of a liquid can be determined by a relative density bottle is as follows. 1. Clean and dry the relative density bottle and weigh it with the help of a physical balance. 2. Fill the bottle up to the brim with liquid whose density is to be measured. Push the stopper gently into the neck of the bottle. The extra liquid which is coming out of it should be cleaned properly. Weigh the bottle containing liquid on the same physical balance. 3. Mass of the empty bottle is equal to m1g. 4. Mass of the bottle plus liquid is equal to m2g. 5. Mass of the liquid is equal to m2 minus m1 multiplied by g. Volume of the bottle is equal to V centimeter cube. Density of liquid is equal to mass of liquid divided by volume of liquid is equal to m2 minus m1 divided by V gram per centimeter cube. Fact: a hydrometer is a floating device that measures the density of liquids. The more dense the liquid, the greater the upthrust and the higher the hydrometer floats. Table: density values of substances. Substances: density gram per centimeter cube. Substances, density, gram per centimeter cube. Water, 4 degrees Celsius. 1. Glass, 2.50. Petrol, 0.7. Iron, 7.8. Kerosene, 0.80. Copper, 8.90. Ice, 0 degrees Celsius. 0.92. Mercury, 13.6. Milk, 1.03. Gold, 19.3. Variation in density of gases and liquids with temperature. We have seen that density of a substance is given as density is equal to mass upon volume. When temperature changes, mass of the object remains constant. But if the volume of the substance changes, the density of the substance also changes. Generally, with the increase in temperature, volume of a substance also increases. This is because when a body is heated, the molecules gain energy and they start vibrating more vigorously. The distance between the molecules increases. This is true for all the molecules of a substance. So, as a whole, the volume of a substance increases. The reverse happens when the temperature decreases. As density is mass per unit volume, so with the increase in volume, density decreases. This is more prominent in fluids. The gases and liquids together are called fluids. When a fluid is heated, the part of the fluid which is nearer to the heat source gets more heat, and thus the temperature of that part becomes more than the remaining part. As different parts have different densities, it generates a flow of heat from the hotter to the colder part of the fluid called convection current. The process by which heat flows from the hotter to the colder part of a fluid is called convection. When a liquid is heated, it expands and its density decreases. The warmer liquid, being lighter, moves up, and the cooler liquid, being heavier, comes down to take its place. This liquid now gets heated, becomes less dense, and again moves up. Thus, a convection current is set up. This process continues. Activity: to measure the volume of an irregular solid using a measuring cylinder. Take some water in a beaker and put some potassium permanganate in it. Put the beaker over the flame. As the water is heated, the red particles of potassium permanganate move upwards. This becomes more vigorous when the temperature of liquid increases. It happens because when liquid becomes hot, it becomes lighter and it starts rising, and cold portion of the liquid comes down. Applications: 1. Ventilators are constructed at top of the walls in rooms because it allows the hot air to go out. 2. Cooling unit in a fridge is fitted at the top because the hot air rises up, and when it comes in contact to it, it becomes cool and comes down. Floating and sinking of an object depends upon the densities of the object and the liquid in which it floats. 1. When the density of an object is less than the density of a liquid, it will float on the liquid. Example: cork has less density than water, that is why it flows on it. 2. When the density of an object is more than the density of liquid, it will sink in it. Example: iron has density 7.8 gram per centimeter cube and water has density 1 gram per centimeter cube. Iron is heavier than water, hence it will sink in it. But the density of mercury is 13.6 gram per centimeter cube. If iron is put in mercury, it will float on mercury because iron is lighter than mercury. Also, we can say that 1. If relative density of a body is greater than 1, it will sink in water. 2. If relative density of a body is less than 1, it will float on water. Applications: 1. To measure the density of a liquid directly, a hydrometer is used. A hydrometer is usually made of glass and consists of a cylindrical stem with graduation and a bulb weighted with mercury or lead to make it float upright. The liquid to be tested is poured into a tall jar and the hydrometer is gently lowered into the liquid until it floats freely. The point at which the surface of the liquid touches the stem of the hydrometer is noted. This reading gives the relative density of the given liquid. Hydrometer is also used in testing the purity of the milk and to check if lead-acid batteries are fully charged or not. 2. An iron nail sinks in water, but an iron ship floats in water. Why? It is because the bottom of an iron ship has a huge cavity filled with air, which reduces the ship's average density. As the average density of the ship becomes less than water, it floats. 3. Flotation of submarines. A submarine is provided with a ballast tank. When its ballast tank is filled with water, its average density becomes more than seawater. So, it dives into the water. When the water is forced out from its ballast tank, its average density becomes less than that of water. So, the submarine rises to the surface of water. Comparison of densities in 3 states of matter. Matter exists in 3 states, that is, solids, liquids, and gases. Each state has its own special characteristics. 1. Solid state, characterized by definite shape and definite volume, thus having higher density than liquids. 2. Liquid state, characterized by lack of definite shape but definite volume, thus having high density than gases but lower than solids. 3. Gaseous state, characterized by lack of definite shape and volume, thus having low density than solids and liquids.
Subscribe to Durgavati International School and press the bell icon for more updates.